Hey, welcome back. Today is the 23rd. It's a Monday, 10:30 in the morning, and I have coffee brewing. So today what we're going to be talking about is functions. Now, functions are going to be the easiest thing. So the way I want to describe functions, things are or are not functions. That's how we're going to be solving these. Either yes or no, this is a function, or this is not a function. So the first thing I'm going to draw here, try and guess it before I get to it. Let me clear this one time and zoom in. I'm getting pretty good at using this clever board. Hopefully you start to realize that I'm better than I was, except when I try and write with the eraser. So I'm going to start by drawing a little picture and try and guess what this is. At home shouting, square, SpongeBob. Try and guess what I'm drawing before I draw it. Have you guessed what it is yet? It is, of course, a vending machine. I'm going to give some quick vending machine items here. So we have a Sprite, a 7-Up, a Mountain Dew, and of course, now, I want you to think about functions like a vending machine, where we have inputs on the side. These are the inputs. And then we have an output, and that's what comes out. Now, what comes out might or might not be what we asked for, but that is not what's going to be defining what is or what is not a function. So I want you to imagine that you come walking up to this vending machine, and you're real happy because you have your favorite drink, and your favorite drink is, of course, a Sprite. So you click the button that says Sprite, and a Sprite comes falling out, and you're happy. But then you decide that you want 200 more, so you press that Sprite button 200 times, and 200 more Sprites fall out, and you leave because you are very happy. And the next day, you come walking up again, and this time you're a little less happy because you don't want a Sprite anymore. This time you want a Dr. Pepper. That's you sad. So you press that Dr. Pepper button, and to your surprise, a 7-Up comes out. And you press that Dr. Pepper button 200 times, and 200 7-Ups come out. So you're thinking to yourself, every time I press this Dr. Pepper button, a 7-Up comes out. And then you leave, unhappy that you did not get the drink that you wanted. And then the third day, you come back again. This time you're colored in red. And this time you're unsure what you want. So you press that 7-Up button. Something you haven't tried before. You press 7-Up button, and out comes a Mountain Dew. And you're like, well, that's just like yesterday. So you press 7-Up button again, and this time a 7-Up comes out. So we press the 7-Up button twice, and two different things have come out. Now we don't know what's going to be next. And that is the idea of a function. Something is a function. I'm going to write this definition down. Something is a function if for every input, there is only one output. Now, I want you to go back to those first 3 days. The first day, you press the Sprite button, and Sprite came out. So if you inputted a Sprite, Sprite came out. Second day, you push the Dr. Pepper button, not Dr. Pepper came out, but it was the same thing every time. So for every time you inputted Dr. Pepper, only one thing came out. I think it was that you said Mountain Dew or something. But the third day, when you push that 7-Up button, and something came out, and then something else came out. Then there was not one output. There were two different outputs, and that's when this vending machine stopped being a function. So there's 3 different types that we're going to be going over. And the first one's called a mapping. First one is called a mapping. This is what a mapping looks like. This is your first example. This is EX1, example 1. A mapping looks like this. It's these 2 big ovals with some numbers inside. I'll put 1, 2, and 3, 4, and 5. Always on the left is the input. Always on the right is the output. And the input from now on, we're going to just call that X, and the output from now on, we're going to call that Y. But the way a mapping works is like this. If you input a 1, you would get a 4 back. I'm just kind of making this up. If you input a 2, you get a 4 back. And if you input a 3, you get a 5. This is very much like the vending machine, except the 1, 2, and 3 are buttons, and the 4 and 5 are the sodas that come falling out. Currently, right now, this is a function. Because for every one input, there's one output. Some of the inputs have the same output, but that's okay because each one only has one output. Think of a different example. That's a mapping. Making two more. Fill it with numbers. 2, 3, and 5, 6, and 7. I'm gonna draw these lines again. The 2 becomes a 6. The 3 becomes a 6. The 5 becomes a 7, and the 3 becomes a 7. This is not a function. And once again, this is the input, this is the output. This is not a function. Because when I press that button 3, I have two options, either a 6 or a 7. That means that that output or that input has two different outputs. So because of this 3 having two lines coming off it, this is no longer a function. Let's look at this. Let's take these and turn these into points. So I'm going to keep going with these. I'm going to turn these into points. So this first one here, we have 1 and 4, 2 and 4, and 3 and 5. Just points, like points on a grid, points on a graph. 1 and 4, 2 and 4, 3 and 5. This is a function still. And I can tell that very quickly because there are no repeating x values. It's a very easy way, it's a very easy way to just look at it and determine is or is not a function. And right here, when I look at this, I say, yes, this is a function. If all I could see were these points, I say, yes, this is a function because there's no repeated x values. If I look at this one over here, and I turn these into points the exact same way, 2 becomes 6. 3 also becomes 6. 3 can become 7, and 5 can become 7. This one is not a function because we have repeated x values. This is the same thing. If I input a 3, the output could be a 6 or a 7. So that's going to lead me to my second definition, my second rule. Pretty major rule here. In a function, the x does not repeat. It's a pretty easy way to remember this. In a function, the x does not repeat. You're going to hear me say this a lot. In a function, the x does not repeat. So on the left side here, yes, this is a function, 1, 2, and 3. And over here, this is not a function because we have 2, 3, 3, and 5. So repeated x values means not a function. We have one more to do. And this is going to be, those points were technically the second example. So we have one more to do, and it is about a graph. Now, graphs, you may be saying, Mr. Weller, that was so easy. All I have to do is remember that in a function, the x does not repeat, and I'm done. And you may think, could it be any easier? And the answer is yes. With 3 letters, V, L, and T. These, of course, do stand for Velociraptors lament tomatoes. That's what one of my students told me. This stands for vertical line test. Vertical line test. Big deal, this vertical line test. Big deal. So if I give you a graph, I'll make the graph look like this. Arrow here, arrow here. And I ask you, is this graph a function? You would apply the vertical line test. And here's what you're going to do. You're going to draw a straight line. I'm going to use highlighter here. You're going to draw a straight line, top to bottom, all over this graph, perfectly vertical. And if you cross the green line in more than one place, it's not a function. So I'll start right here. I'm going to draw a vertical line here. Yep. So far, that's it only hit the graph in one place. It hit the graph right here. I'll highlight this again so you understand what I'm talking about. It hit the graph right there. One time, I continue. I draw a straight line here. Hit the graph one time, 3 times. It looks like 2 times here. These are supposed to be perfectly straight. And then once again, I hit the graph only 1 time. So because I hit the graph right here, because we hit the green line more than once, this whole thing is not a function. Not a function. And the reasoning behind that, the reasoning behind that is because this is the x-axis, this is the y-axis. And at this spot right here, whatever number this is, there are 2 y values for that one number. So let's look at another one. Another graph where we can apply the vertical line test. I'll draw this out. You're now asking yourself, is this a function? And the answer is yes, it is a function. If I apply the vertical line test, no matter where I draw this straight line, I only ever hit the graph in one place. And when I say the graph, I don't mean the grid. I don't mean the axis. I just mean the plotted line. Let's do one more. So this one is a function. One more. And I'm going to use these as just points on a graph. We're going to make these kind of big so that we can tell right where they are. Turn on grid. Not that. Yes, perfect. Okay. So if I add some points here, like I'll put one like right. Oh no, I put one like right here. Put one right there and there and right there and right there, and I'll put one right here. I ask you, is this a function? You would still apply the vertical line test. So I would draw a straight line right there and say, yeah, it only hits the graph once. Only hits the graph once. And then right here, this hits the graph more than once. Once. So this is not a function. And it's not a function because of that line right there. I tried to make these right on top of each other. Because this crosses this spot more than once, it crosses those more than once in a straight line. They're right on top of each other. This is not a function. And that is it for functions. In a function, the x does not repeat. Vertical line test. These are some pretty notes. I like all the colors. And then don't forget to go get yourself a soda. Bye, everybody.